Hello and welcome to Sarat Chandra IAS Academy. Your dreams are our mission. In the last lecture, we had read about Indian monsoon. We had seen its causative factors as well as distribution. So in this lecture, I'll move things forward from there so that we can cover the full topic in this lecture now. We are dedicated towards mapping a lot, and I will post the PDF of this lecture in the group as soon as possible so that you can read from there also. So the torrential rainstorm often cause violent landslides and widespread floods. So this can be seen this year in Uttarakhand also and Himachal Pradesh as well. So entire villages have been swept away during monsoon rain. Despite the potential for destruction, the summer monsoons are welcomed in India. So why? Because of the crop production. So India is a monsoon dependent country for its crop production. So farmers depend on the rains to irrigate their land. Additionally, a great deal of India's electricity is generated by water power provided by the monsoon rains. So this is very important. Whenever there is an upper riparian estate and the water is going towards the lower estate, there can be a dam in between which will produce electricity. Alright, sometimes the water can also be stored as potential energy. Let's say this is a height. So water can fall down again when it is needed. So by consuming this electricity here, it can be stored as a potential energy. All right. So the monsoon delivers most of India's rainfall and has a key impact on the economy. In the two ways we have already told. One is the cropping. And second is the energy production. So only a third of India's crops grow on irrigated land, and a weak monsoon can wipe out many incomes and shrink demand for farm equipment and consumer goods. So this is how both the things are connected. Monsoon rainfalls are unreliable in that the amount varies considerably from year to year. Why? There are various different factors. So low rainfall causes great problems for agriculture and water supplies in general. And in the Indus River, the flood problem is often made worse because the monsoon rainfall can coincide with high river levels in its tributaries, caused by water from the melting mountain snows of the Himalayas. So here we can see the effect of climate change as well. Alright, so this is a major portion of what we want to see. Alright. Interannual variations of Indian summer monsoon. So interannual means year to year. So some data from here is important for our answer writing. Just a second. So the rainfall during the India's summer monsoon. We are talking specifically about the summer monsoon, but it involves both the branches, the Arabian Sea branch and as well as the BOB branch. So June, July, August and September show considerable interannual and interseasonal variability. So the question arises why? State the reasons for interannual variations of Indian summer monsoon. This can be itself a question. Alright. So over any part of India, some years a lot of rainfall occurs, causing floods, with some other years rainfall amount received is much less, causing drought-like situations. So this year-to-year variation is known as interannual variability of monsoon rainfall. This interannual variability in the summer monsoon rainfall has a profound effect on the socio-economic well-being of India. Hence, the ability to forecast such events become the focus of various meteorological studies. Alright, so we are thinking about now foreseeing as how it can be foreseen. So let's come to our next map, which is monsoon rainfall variability, all India mean rainfall. So here what we can see is this graph is plotted between, just a second. So this graph is plotted between the years and the rainfall anomaly. That means percentage of the mean. Mean means average. Average rainfall which is expected in India. So whenever we are seeing any blue line, let's say, these are the effects. This is the La Nina, El Nino, this is normal, this is flood, this is drought. Okay. So when we are seeing these lines, so we are seeing till let's say 2000 or 2003 from 1870s. So what we can see that both the extremes, these are the flooding events, the blue ones, are often associated with these circles which are described as the La Nina events. Only a few such circles, just a second. So only a few such circles, such events are without the circle, such as this, let's say this, are without the La Nina events. but are often followed by years which have La Nina events. Alright. So we can see that La Nina is often associated with high rainfall in India. And on contrary to that, the El Nino events, such as these, will always bring a drought. Alright. So we can ascertain that India's rainfall is strictly associated with or significantly associated with either La Nina or El Nino variables. So this is the year of the El Nino. So we can expect some drought-like situation. Alright, drought means a period of lesser rainfall than average. So this is one factor. There are other factors as well. Let's talk about the predictability. This is also an important topic. So short range and medium predictions of rainfall over any region, including that over the Indian region, depend upon how well the initial state of the atmosphere has been defined with large number of very good quality observed data. So it's more or less about the statistics. In the tropical region, it is believed that the predictability of day-to-day weather patterns is restricted to 3-4 days because the factors that can change the weather is little unstable. It can rain anytime in the tropical areas. When we hear about the forest, let's say tropical forests. So these are there are many tropical forests in India, whether it is Western Ghats or Eastern Ghats. So it can rain there and it can rain there for days. Alright. So observational studies show that Indian monsoon seasonal rainfall is linked with several surface boundary conditions like sea surface temperature, Indian Ocean land surface temperature, Eurasian and Himalayan snow cover, etc. So climate change is actually changing everything, each of them, and will have a very, very strong effect on the Indian monsoon. These are the factors which affect the Indian monsoon. Alright, so these are 16 parameter power regression and parametric models. So these are the factors. So most importantly, it is El Nino and El Nino previous year. Then there is South Indian Ocean SST, surface temperature, East Coast India temperature, Arabian Sea SST, the Central Indian temperature. Mostly, of course, they are all related with the temperature because we are talking about the seasonal reversal of winds, and it's only and only dependent upon the temperature of either the sea and land and the relative temperature difference between them. There is also Darwin pressure tendency, NH temperature, equatorial pressure. So pressure and all the gradients are dependent upon the temperature. Alright. These two are related to the climate change, let's say snow cover and Eurasian snow cover and Himalayan snow cover. So more the temperature there will be, lesser the snow cover will be. And it will affect the wind positions and wind directions. Methods of predicting Indian monsoon rainfall is that IMD uses the statistical model for making seasonal predictions, studies of historic data sets, and the most commonly used statistics technique for seasonal prediction is the linear regression analysis. So this is also it can be a question in the prelims, that linear regression analysis is used in the study of what? Indian monsoon, or let's say climate change or snow cover on Himalayas or something else. So Indian monsoon will be the answer here. Alright. Let's now move on to the Hadley circulation. These are some circulation cells which play an important role in the Indian monsoon. So they are a little extra topics which we should cover. Alright. So when we are talking about the Hadley circulation, why are we talking about it? It's because of its vastness. It's a rather large phenomena and its circulation spans half of the surface area of the globe. And variability within this system affects the lives of billions of people. So we don't need to go too deep in this, but we'll just see from the upper portion. So a monsoon circulation associated with the Hadley cell. So the Hadley cell is a circulation pattern. First of all, this is important to note down and remember that every cell is a circulation pattern of the air. And air is essentially, you know, the components of air, whether it's a gaseous mixture of various different gases. But what we are talking about here is that the mixture is heated layer wise on various different temperatures. We all know that hot air rises and cold air sets down. So this is essentially why air circulates. Alright. Now whether this circulates in this pattern or this pattern, or on which tropics this air comes down again. Alright, so this makes a cell. So we are talking about the Hadley cell. So when we see here is that the 0 degree equator, the 30-degree north and 30-degree south. So what we see that in and around the equator, what happens that the air rises. Alright, the air reaches on the top, both sides of the equator. So let's say if we make the earth like this, please adjust with the circle. So we are talking about this situation. Alright, and the air is going towards the north. So we are talking about this. So we are talking about, this is 0 degree. Let's say we are talking about a 30-degree north. Alright, so we are saying 30-degree north, and then it is coming down. Alright, so this sort of movement is there. And same when we see towards the south. So air is rising, let's say, coming down like this. Okay, so on this portion where the top of the hot air rises, this creates a low pressure zone. And this is the area where it rains, as you can see here. Alright, so let's read about this. So Hadley cell is circulation pattern that dominates the tropical atmosphere. So this is to be noted that Hadley cell is related to the tropical atmosphere, because we are talking between 0 to 30 degrees. Alright, so if we are taking 0 degree at equator, we are talking about the 30 degrees. And we know that 0 to 23.5 degree plus and minus are our tropics. Alright, so let's say 90 degree we are taking the north. So we are talking about 0 to just 30 degree. So this 60 degree area is, we are not concerned with this. We are talking about this only 30 degree area. Alright. On the earth we will see it like this. This is, let's say, 90 degree north. This is 0 degree equator. So we are talking about circulation in this area, which is 30 degree. And it is related to our tropics, such as they are 23.5 degrees. Okay, so we are talking about this area. So tropical atmosphere with rising motion near the equator pole. Upwards flow 10-15 kilometers above the surface. Descending motion in subtropics and equatorward flow near the surface. So we will be having a descending motion here. Alright. And flow near the surface. The circulation is intimately related to the trade winds, tropical rain belt, subtropical desert and the jet streams. So it's sort of like this. Alright. There are a few other cells also. Let me just show you. So when we are talking about, let me just make this sphere a little bit narrow. So when we are talking about the Hadley cell, it's between here 0 to 30. Then there is Ferrel cell. So it works in the same way. Alright, and there is this polar cell. So right now no need to read about them, both these Hadley cell and Ferrel cell. Okay, these just work in the opposite direction like this. Alright. So what is the significance of this Hadley cell? The Hadley cell carries heat and moisture from tropics to the northern and southern mid latitudes. Alright. Let's just now see about this. So now when we see the Indian subcontinent, let's say, alright, we see that Indian subcontinent is this, and let's say equatorial Indian Ocean is this. So during the monsoon, what we are seeing is that low pressure zone is being created here. Alright. So the rising arm of the Hadley cell, alright, is above the Indian subcontinent, and it's coming towards this side. Okay. Towards the Indian Ocean, the equatorial Indian Ocean, while the monsoon winds are blowing opposite. Okay, this is like this, and the monsoon winds are blowing in opposite direction. So this is why what we can say that monsoon circulation is opposite to the conventional Hadley circulation. We can see this here. This is evaporation and moisture transport through the monsoon winds. Alright, and Hadley circulation is what? Such that the air rising from here, alright, and going towards the Indian Ocean. So what we need to conclude here is that monsoon circulation is opposite to the conventional Hadley circulation. So this is in relation with the Hadley circulation, the factor affecting Indian monsoon. So it oppositely affects. However, it actually strengthens the Indian monsoon. One is Walker circulation. The Walker circulation is an atmospheric circulation of air at the equatorial Pacific Ocean, responsible for creating ocean upwelling off the coast of Peru and Ecuador. So we are talking about the Southern Americas here. All right. So we are talking about the Peru and Ecuador, this portion. So upwelling is happening here. All right. That means the water which was on the downside, the cold water, the cold sea water is coming upwards toward the coast. So this is good for fishing. So this brings the nutrient-rich cold water to the surface, increasing fishing stocks. It was discovered by Jacob Bertens and it was named after the English physicist Gilbert Walker, who discovered the southern oscillation. The Walker circulation is caused by the pressure gradient force that results from a high pressure system over the eastern Pacific Ocean, low pressure system over the Indonesia. So what we can see here is that this whole temperature cycle also affects the monsoon on other countries. Just let's see this diagram here. So quickly seeing this, not very important, but it does affect Indian monsoon also. That the warm systems are developed here. Let's say warm, wet and low pressure zones are developed here. So the air, moisture laden air from this side, the South African side, comes towards here and rains. Then it rises as it becomes lighter and hotter, and then comes down here again from where it can carry moisture again. So this is a clockwise system. Alright, it affects the South African and Australian coasts between the El Nino years, which eventually affect the India as well. From this side of the Australia, we'll see that. So this we don't need to see. Hadley circulation is intimately related to trade winds, tropical rain belts and subtropical deserts and the jet streams. You can just read about them when I put it in the group. Trade winds basically are pattern of wind that are found in bands across the Earth's equatorial region. Trade winds we have all seen. We always read about them. These are the trade winds. Why are they trade winds? Because they help during the trades, sea trades. Alright, jet streams are fast flowing, relatively narrow air currents found in the atmosphere at around 11 kilometers height above the surface of the earth, just under the tropopause. So you can read about them. They also affect the Indian monsoon, especially jet streams. Alright, but let's talk more importantly about the El Nino and the La Nina in relation to Indian monsoon, because they are more important. So El Nino and La Nina are defined as sustained sea surface temperature anomalies of magnitude greater than 0.5 degrees Celsius across the central tropical Pacific Ocean. So please remember, they are more than weather events. Alright. Sometimes what happens that El Nino exists, but drought condition may not exist. El Nino does not mean 100% drought. Alright. Neither the La Nina means 100% flood. So while they do affect, they can also exist without causing any effect. So please remember, what are they? They are temperature anomalies. Okay, they are not exclusively weather phenomenon. So what are El Nino and La Nina? They are temperature anomalies. And please also remember how much is the extent. So this is 0.5 degree Celsius sustained temperature, both sides of the zone. So when the condition is met for period of less than 5 months, it is classified as El Nino or La Nina conditions, which means if the anomaly persists for 5 months or longer, it is classified in El Nino or La Nina episode. Historically, it has occurred at irregular intervals of 2 to 7 years and has usually lasted 1 or 2 years. The reason is unknown for this. There are many various reasons, but it's a part of how the globe functions, how the earth functions, and we cannot divide everything annually. For us humans, everything is, let's say, going across annually in a year, which is marked by the Earth's rotation toward the sun. So we see that it has completed one cycle, but everything is not cyclic. Some things are very irregular also. So the first signs of an El Nino are rise in air pressure over the Indian Ocean, Indonesia and Australia. So what we are seeing here are basically rise in air pressure, fall in air pressure over Tahiti and rest of the central and eastern Pacific Ocean, and trade winds in the South Pacific weaken or head east. So this is an El Nino year. You can correlate with the current ongoing happenings. So warm air rises near Peru, causing rain in the deserts there, and warm water spreads from West Pacific and Indian Ocean to the East Pacific. It takes the rain with it, causing rainfall in normally dry areas and extensive drought in eastern areas. What you basically see here is that in during the El Nino years, the rain will be directed towards the South America. Simply understand by this South America, and there is drought conditions in India or dry conditions in India. All right. On the other hand, during the La Nina, the cold upwelling will help be held here in the South American region. All right, and there will be rainfall, high rainfall towards Australia and India. So it's good for both the sides except for some flood conditions in India. All right, that is related with the disaster management, not very much with the geography. So for India, a continuous and homogeneous record is available since 1871, and monsoon rainfall has been increasing. This is because of the global warming. All right, and decreasing 0 -6 to -8% per country over East Madhya Pradesh and adjoining areas, Northeast India and part of Gujarat and Kerala. So this is happening because of, let's say, climate change, and there are further events. So a weak monsoon is a result of large negative SOI, Southern Oscillation Index. So what is a Southern Oscillation Index? There is some temperature index going on between the Indian Ocean as well. This is known as ENSO. Alright, we'll see about this very soon. And El Nino events. El Nino events are between the Australia and South America. So they are the more related to Pacific Ocean. So a strong monsoon is a result of large positive SOI and the absence of El Nino events. So not to directly influence the Indian monsoon, but indirectly. And during the period, 11 of 21 droughts were El Nino years. So more than 50%, let's say. So El Nino directly influenced the Indian Ocean or Indian monsoon. The periods were characterized by frequent droughts. The periods were practically drought-free, let's say. This data is not important. Just remember that El Nino and La Nina affect Indian monsoon in a positive and negative way. Alright, sorry, negative and positive way. So relationship of Equino and ENSO, we'll see this also. So comparison of evolution of normal summer monsoon of 2003 with the anticipated drought of 2002 led to the investigation of the role of the deep convection in the atmosphere over the equatorial Indian Ocean. The link of the Indian monsoon to event over the equatorial Indian Ocean is an important as well known link to the dramatic events over the Pacific, El Nino and ENSO. So basically what are we saying? That even the far reached oceans have an impact on the Indian monsoon. So we are talking about the travel of air. So very of course it maintains a continuity from somewhere. It's not that it arises directly out of air. So of course they will have an impact. Alright. So over the equatorial Indian Ocean, enhancement of deep convection in the atmospheric over a western part is generally associated with suppression over the eastern part and vice versa. So you can read about both these things, Equino and ENSO. We may not have time to completely explain these things, but just note down in your mind map. Lastly, we can talk about the monsoon depression. So a depression that forms within the monsoon trough. Alright, a term that is most frequently used to describe weak cyclonic disturbances from over Bay of Bengal and generally track northwestward over the Indian subcontinent. So these occasionally intensify into tropical cyclones if they remain over warm ocean with long enough. So here we can just see this, the monsoon depression. Alright, so it's inherently it's air at the end and it can make its ways. It's not always going very directly to somewhere. Alright, a depression can occur here and it may turn into a cyclone. Alright. So there are many different criteria which IMD has followed. They are disturbances in the Indian monsoon. These are internal disturbances. So I've included this. These are low pressure area, depression, deep depression, cyclonic storm, super cyclonic storm. So these are related to the air systems where the air is rotating at certain speeds. The air speed is measured in the knots. So 120 knots or above will be a super cyclonic storm. Alright, 1 knot is around 2 kmph or 1.85 kmph. Alright. So Indian monsoon can be affected by pollution also over Indian Ocean. So this is a theme that you can let's say describe by yourself or research by yourself. One thing is monsoon and climate change. So of course climate change is affecting monsoons, the distribution as well as the rainfall. So global warming will change condition in the sea more slowly than conditions on land because of the difference in the rate of response to heating, a concept familiar from the sea breeze. So what will happen with global warming? Rainfall will basically increase, but floods will also increase, and moisture will also increase. There can be submersion of the land areas also, just which was recently seen in South Africa. You could see, and there can be flood in major countries such as Pakistan also, which we saw recently, and Northeast India also we saw it recently. Alright, so these are separate phenomena. Conversely, in winter, we should expect less of a difference as the land refuses to get quite as cold as previously. So the winter monsoon should weaken, as should any of the nutrients supplying coastal upwelling associated with winter monsoons. So will climate change affect India's monsoon seasons? So the answer is yes. Alright. So scientists predict that by the end of the century, the country will experience a 3 to 5 degrees Celsius temperature increase and 20% rise in all summer monsoon rainfall. So this is same as what I have told earlier. One topic is future changes in monsoon variability. So India is already vulnerable to variations in the monsoon, both from year to year and within the season. One of the key questions in climate change is whether the remarkable stability of monsoon rains will continue. So it will not continue. Alright, if the climate change takes place at the same pace. So most model predicts a modest increase in interannual variability, but to differing degrees. Alright. At the heart of this are the projection of what will happen to the El Nino, whether it will become stronger and more frequent, since El Nino has dominant influence on monsoon variability. So answer of this is yet unknown. So we can only wait to see with the increasing climate change and global warming what can happen, because we yet don't understand what actually triggers the El Nino. So monsoon is important and scientists are engaged in understanding the variability. Hope in future we have more accurate predictions of Indian monsoon rainfalls. So this was about the Indian monsoon. We learned many things, that what causes the Indian monsoon, what are the factors causing, what is the retreating monsoon. Right now it's retreating. Alright, and some areas may face a drought-like situation. There are various rain-shadowed area also of various different monsoon, such as Tamil Nadu comes under the rain shadow area of, let's say, the southwest monsoon. Alright, so it is also facing some drought issues, drinking water issues. There is Bangalore also, which is in the rain shadow area, so it's also facing some drinking water issues. We'll see them in the next lecture when we talk about the Kaveri dispute. So this is Yatharth here signing off. Thank you very much for your time and understanding. I will see you very soon. Have a good day and keep studying.